Hello. Good evening, everyone. We can start the session.
Good evening, sir.
Okay. Let me share my screen. Okay. Okay. Okay.
So are we started yet? Because I joined a bit late, I guess.
Yes.
So, what did you do? Like, how much did you proceed?
None.
Okay, sir.
Okay, so this is the collab from last class. We in last class we did some amount of pre-processing. We were able to at least create. So this was the data, and we were able to, I think, create only one kind that this much, right? So this is a column transformer that does imputation part. So this one is done. Now what we are going to do is, so after imputation is done, we do encoding. So we'll do all the ordinal encoding or one hot encoding, right? So something like that we'll do. And then after encoding we do scaling, so that we will also add in a pipeline. And then after scaling, maybe we want to do model training, we can do that. Or before model training you can do feature selection also. So that component also we can add into the pipeline, right? So this all few components we can add to the pipeline, and then it will actually look like a pipeline, like kind of structure it will look like. As of now it doesn't look like much. If somebody don't have this, I can share in the here. So this collab contains the link also. So this is the link for the data set which I am about to go about to upload on car price predictions. Okay. So that okay. So I uploaded the data. You can see here. So I use this first option given in files, right? So this folder kind of thing, and here it is there. So I can upload the data set. Now I just need to run this. Okay, so that will load the data set, and rest of the I can run it again, and it will not affect the what do you call output, right? So output will be same. So I won't run it again. Uh, so one thing I'll do is I'll run some command which are necessary, like train test split, maybe whatever imputed imported or something like that. Okay, pipeline. Fine. So where is train test split? Okay, here. It was here only. So this is my uh, train data and test data I'll get from this. I run this train test split part. Now, uh, you know, so I'll go down, and at the last we did this. So let's just run this. NP is few things we can do is, so it would be better if we do importing all the things at the first cell. I do that. So whenever if there is some error, I come back to the first cell and put it there. So that whenever I run it again and again, I don't have to so this error message will not appear, right? Because you imported somewhere. So that is a good practice maybe you can do like this. So learn dot pre-processing. I have to import one hot encoder because that's what we are going to use. Ordinal encoder also we are going to use. Standard scalar also we are going to use, and I think that's about all. Few more things I need to import is pipeline. I need to import pipeline. Yeah, and column transformer also. Import column. Okay, so this all thing I imported from different part. You can see I use model selection for train test split. I use pre-processing for this thing, like one hot encoder or ordinary encoder standard scalar, and I use pipeline for pipeline and this thing. You might not remember this because this is your first time doing this, but uh, as you practice, maybe you will remember it. Uh, so what you can do initially is maybe you can go to sklearn, and what you can do, you can let's say I'm here, right? So these are the things. Some user guide, okay. Maybe example. So okay, so yeah, so this data set transformation or something, if you go there, they will explain how you can do, let's say, pipeline and all, right? So from this, so this module name, like I don't expect you to remember it now, that why I did this way, or from why I wrote pre-processing only and not something else. So that's the way the library is built, right? So this, now we are using already Python library which was created. So in that they have created some structures thing, right? That model selection will have some kind of um, functions in it. So like train test split is one of that kind of function. Then pre-processing will have some kind of functions. So they have created it. Now we just have to use it, right? So uh, we might not know what exists where, and that's where you have to use this pipeline thing. So as of now, you have to actually copy the things, right? That okay, what is happening where I need this kind of thing, because uh, let's say you come across data, you want to transform it, right? So you want to do some kind of thing, then you can maybe search here. Or another thing is you might you might wanted to look at the last in week 2 a notebook will be given, right? In course content itself given, I think, where the complete process was done, right? MLP, what do you call it? In supplementary content, this collab resources will be shared with you, and I think it is there for week 2. Pre-processing, data loading, SQL introduction. So I think end to end, right? So this is a workbook or something. So where they would have showed how to actually write a code of some kind, like how to import or something, right? Let's say these are, or it's there in like week 3 also, like our resources, right, which you if you watch video or something like that, this all thing might be explained how to, which one to use or something like that. For example, this is a scalar introduction, right? Some kind of like estimators. These are estimators. These are predictors, right? That how do you predict your something transformers, and then in that transformers now we are doing fit transform and something like that. We are changing the data. Changing the data is transformation. Learning is kind of fitting, and which like estimators have something like estimators are models. Uh, so I think not here, but let's say pre-processing. So this all collabs have some kind of examples given to you, and some slides are also will be there in this lecture PPT, right, where they they show a code snippet, small amount of code snippet that you can use this for this kind of encoding and all. Right? So this is a data set. What we are trying to achieve, right? So here we are doing actually mean max scalar. How they did it is this way, something, right? So they have given some kind of examples in this scaling, imputation, handling, categorical handling. So let's say this is a categorical data. How do you handle it? So they are doing one hot encoding. You can see this is the way they did it, and that's why they imported one hot encoder from here, and then they showed an example of it. Okay, something like this. So this is what we are also doing. But I mean, just in case if you don't know how or why I am doing in this way, because it should be done this way. Okay, like I I didn't know when I started. Um, I went through this several times, so I know it. Okay, it's basically like the process somebody else followed it. You have to just walk through their steps. Okay, that this is the way it should be. Nothing like nothing like some random numbers or random things are written here. Okay, this all done by somebody, and we are also following that. That's all. So I'll just import everything here. If some errors comes up, I will come back here and then add that thing, whatever is the importing error, right? So okay, might be simple imputer might give an error. I think I kind of must have, yeah, see. So from sklearn dot impute, I have to import simple imputer. Okay, so this is that. Uh, we can actually do it. So this is okay. So this is then colors are found in column. Hmm. Given column is not that. Okay, so I gave kilometers driven, present price. Okay, this is something I shouldn't have given, right? So I think I remember I was kind of explaining the um that how do you write, right? So this thing, that's why might not work. So but we are supposed to, what we are supposed to do is we should like uh basically this thing only. So string dot is null. So wherever null values are there, that we are going to impute, right? That is the idea behind this sklearn imputing. So this three were there. So I think I used one only. That kilometers are there, and fuel type is there, which for which I use most frequent value, and owner is there, for which I use mean kind of thing. You can use multiple for one also, not an issue. Let's say you wanted to have only use median for both of them, that is also valid, right? Depends on how you choose. So this is something like statistically you have to do it. Okay, and I can actually remove this, right? So something like that. This will also work. Uh, so this is how my new data frame will look like. I use this thing called set output to pandas explicitly so that we can actually visualize it. Otherwise, it will give you NumPy metrics, and this column names and all will not be there in NumPy metrics. Okay? Just values will be there. Um, so okay, now let's write the code for what we are going to do is we will do we'll create a pipeline, and in the pipeline, okay, build a pipeline. And what are going to be the component of that? So pipeline is like continuous thing. Okay, so whatever data you give, you want to do all the things with that, right? So first I can actually give imputer, which we created here. So this thing, right, the whole thing which we created here, column transformer, you can maybe think that I'm gonna give as a first component, right? So first will be this imputation related imputation column transformer. Okay, that I'm going to give. Then second, I'm going to give uh, something which can do encoding, right? So feature encoding or encoding will be there. So for encoding also, I'll require another column transformer. So I'll do that and then merge both of them. Okay. Now third, I want to do is scaling, right? So scaling will not require scaling will not require you to have different column transformer or different columns to choose. Yeah, you can just directly do scaling to all of them. Not an issue. You can do that. If you don't want to do it, then there is a way to do that also. Like you wanted to select some columns, um, then maybe you can choose selection part for selection of columns. You can maybe use column transform for that also, right? So there are several ways to write this. This is one of that way. Maybe another idea is you can choose a column first at the start, you choose it, and then write all of the things you are going to do with that, which is also a popular technique. Like that you choose a column, then you fix on that column that what are you going to do on that. You create a pipeline for that, right? Everything is written in pipeline, because now one column is going to come inside, and then what you want, what kind of transformation you want to do one after another, right? So that kind of thing you can do. um, so first divide and then choose. Here we are dividing it come again and again and doing the process. Not much difference, both will result the same output or same what required. The columns will be a little bit interchanged here and there, but that is okay. Machine learning will learn it that way. Okay. So okay, so let me write from. No, I don't need to impute anything. So I'll create another column transformer for encoding, right? So encoding, um, encoding columns. Okay, so I'll do one column transformer. Okay, I need to give something called transformers, right? So it should be a array, right? So this array I have to write like what is this array going to be? It's this, right? So let's say encoding. Encoding. Okay. Transformer. So this array will be there, and then I'll write tuples inside it. So how will I know which columns I'm going to do? I have to look into the data for that. So let's do that.
Sir, are you using the same collab
Yes.
which you said?
Yes.
Uh,
Uh, okay. So okay. Generally, when we do machine learning, we consider features of data, right? And name is not like something we can consider a feature because it's kind of unique in its own. It has like unique thing, and it doesn't repeat or something, right? So we don't consider names as features. Like let's say student name, or you would have done statistics, right? So some features you would have done for something like a case, you call it in there, that case you use, and then you do it, right? So you can consider car as a case, and we don't have to really encode this, or we can just ignore it also, drop it out, right? Something like that. um, but nonetheless, so let's not do that. For this, I'll drop it, and I'll not do any kind of encoding in this. Now wherever null, okay, wherever this is a fuel type is there, where I have to do something, right? So this is I think we figured out that this all are encoding one kind, like ordinal encoding only. So that is a issue, but okay, ordinal encoding. Then and I have to give the column names. Okay, so let's say I give fuel type, and I give seller type. Sorry, this all should be one hot encoder. I think I messed up. Because they are all nominal data. So for nominal, we use uh, we use one hot encoding. Okay, now should be one hot encoder. Now for one hot encoder, maybe you it's a good idea that you change it to uh, non-path. Like don't give me the sparse output, right? So something like that we should do. Okay. So seller type is another column, and transmission is another there. So I'll give the transmission. Okay. So this is one kind of transformation that I want to do on this all columns. So I mentioned all of them in the as a list, that this all list is there. So this is one tuple, right? So one tuple I wrote. This is the complete tuple that I wrote. Name, what kind of a class you wanted to use. So one hot encoder is the class that I wanted to use for doing the transformation on this all columns. Okay. Now let's just say that I'll use, because I don't have any ordinal data, right? Like some kind of small, medium, large, something like that. It would be there. Then that was great. I can use, for example, since now we are inside this, I'll just use first column. Car name is a ordinal encoder. Okay, just for the sake of doing it. It might not work also. There might be actually it will not work. I think so, because names will not repeat again in the test set, right? So, but nonetheless, let's try it actually. So ordinal encoder. Maybe I can do what is handle unknown. Something I can do here is okay. I need to I need to search for it. That how can I handle unknown? So use encoded value. So if I do that, I think set to use encoded value, you can actually set what you want here, that do that. Okay, so that we can do. So first what we'll do, we'll do handle unknown, and I'll set it to something like use encoded value, right? So this I'll do, and then what kind of that value should be there, that also I'll mention. So that value is going to be, so the good idea is that you don't set it something between 0 to whatever the rows number are there, right? So maybe you can choose maybe very high number, or negative value also work, because the encoding will start from 0. So that we should not do, but we should um we should use either negative number or very big number, which that many rows are not there, right? We are expecting maybe something here, so that's why I don't want to raise another error there, so I am doing that. Now will be denoted as 1. So if it is set to this, the d type parameter must be a float. Okay, let's do something like -1 something. Okay, and then I have to give the column, right, which I wanted to use, which is like car and name, right? So this kind of thing which will create this. So I'll mention this array which I just now wrote, which has tuples. I'll mention that these are the transformation I want. Do I want you to remove rest of the columns, which I'm not using for transformation? No, right? So I'll write remainder is equal to pass through. So this is another through, right? So this is another thing. Now and go. Okay, this encoded columns or encoding column, whatever. So this thing is there. We can check what we are doing. So this is the another column transform which I'm creating, which will do here and something like this, right? So we can do that. So for now, what I'll do is I'll show you how it works. Later on, you will so after this step, I'll just show you, and then we can create pipeline. And we'll add this components into pipeline, so one after another, and then you will realize that okay, how this pipeline is going to build. So in that component, I can add sklearn this what do you call scaling, right? So scalar, if I add, then you will maybe can see the smaller pipeline of it, and that will visualize it. Okay, so for now what I have to do is columns dot fit transform. What I will fit transform my X string, right, as of now. So these are the things. Okay, so see, you are getting this numpy. We don't want that. So what we can do is we can do set output to something like transform it to pandas, something like this. If we do, and then I run it, it will look like this, right? So I did encoding. You can see now only numbers are there. That is nothing like that. There's no category, so there is no strings remain in this, right? Maybe we can maybe let's just store it as a something, and we
Sorry
can
to
do,
interrupt you, sir.
yeah,
Where you write pandas, pass through set output transfer. Okay.
here.
Okay.
Df3 dot, maybe I can do info, must be, you can see all of them are float now. If you see xtrain dot info, it is some see object are there, object. So this object will not being, you have to be careful with this, that these are something you wanted to replace with numbers, so that later on you can train the model on this feature, right? So these features, if required, you have to convert them from string to numbers, right? Float or integer or something. So that thing we are doing here. So now we have all of them are on float, or whichever this fuel type CNG is there and all, right? So this all thing created, and you can see the original columns, right, which are not there now. So basically fuel type, which was original feature, is not there. Like you can see, it's not here. Seller type is also not there. So that column is being removed, and in place of that, the encoded columns are now there. Okay. If you do it with pandas, you have to maybe explicitly do it, that remove these columns and add this column, something like that. But here we don't have to do that. Okay. Now I will do the pipeline thing. So let's say pipe is there. You can name anything, that is not the issue. So in this we have to give steps. Steps is also again a matrix, right? So you can call anything. I generally call step only, but so we don't get confused, I'll just call stp right here. So first what I did is I'll do imputing. Okay, for imputing I'll use my this ct, which I have called it. Maybe what I can do is imputing this thing, and imputing column. So something like this, I give a name to it. So here we have this. Okay, yes, here as well. So this thing I'll add here. Okay, I don't have to add brackets or anything after it. Depends on what kind of thing. So now I'm not writing a class here, right? Earlier I used to write classes. Now it's actually object of column transformer which I'm writing. So not required. Now after imputing, I'm doing encoding. So that thing I'm doing using the encoded columns, right? So this thing I'm using for that. Okay, so these two things are there. Now we can see the pipe. Okay, so this, you can see the pipe is there. So first it will do the imputation, right? On this columns, this 3 columns, the imputation will happen. Rest will be just concatenated, and then it will be sent to the encoding column transformer. Then encoding column transformer again split the data using this. So now So what kind of conflicts can happen is, you can see here I give name as fuel type. Does fuel type going to appear here? So for our case, there is not an issue because we use this set output to this transform thing that make it to pandas. So column name will appear. So there won't be any issue. And but after this column transformer, if I wanted to select a column, then I have to be careful because now my column names are kind of changing in some way, right? So now this columns are changing. Okay. So you have to be careful with that. That how do you replicate the changes? Okay. Uh, so it's a good idea that whenever you create a pipeline of a small kind, you what you can do is you can do like will change. Okay, I think I didn't give reminder here, so I should give remainder equal to pass. Oh no, not here. It should be okay there. It's okay there also there. Here we don't need to give remainder. That is fine. So then why we are getting this warning? I am not sure. No idea. So what I'll do is pipe.fit. Let's say if I do x train. So what I'm going to get at last, right? That's what I wanted to see. And given column is not a column of the data frame. It's not a column of data. This is the error I was talking about. That this kind of error you might see because I use this transformation now. What is going to happen, right? So one more thing we can do here is thing like something I have to do is like this. Okay. So let's say if I do this transformation now, you can see oh okay, CT. No, now its name is changed to something like this. Okay, so now you can see the name are as it is. Earlier it added the prefix with whatever and whatever this thing is happening, right? So if I do this as false, then it will not happen, right? We can do it here also, same thing, but it will not be useful now because now we are actually creating multiple columns from same feature using the one hot encoder, right? So that won't be much useful to us now. So what I have to do is, okay, now it will work, right? So it trained it. Maybe what we can do is we can do transform and see. So you can see now this kind of data set I'm going to get, right? So fuel type CNG, fuel type diesel, petrol, something. It has imputation also done on this, so that thing done. Now you can see scales are not appropriate, right? You can see here 26,000, but here 0, 1 kind of values. So we have to do scaling of this. Present price. So selling price is the target, right? So I never included that. It's in the Y train. Now I have to add. So this pipeline will require one more thing, which is scaling. So I just have to add like this. Scaling, and I'll add that's a standard scaler. Okay, nothing yeah, nothing new of that. Okay, maybe I can do this. Maybe I can do set output here as well if it is supported. Okay, so you see that this kind of transformation will happen. It will come to this another column transformer, then it will go to standard scale. Okay, so this one more component I added here. Now if I run this, so now they are scaled, right? So earlier it wasn't scaled, like year and all, you can see kilometer drivens. Now they are scaled. So this all values got scaled now. Okay. Now some, if you wanted to select columns in this also, you have to write this column transformer that I wanted to select the column. So for selection also, it's like good idea that you use column transformer just for that, right? So selection part you can do it. So one we did it. So this is the like pre-processing pipeline. Now what you want to do is maybe let's say feature selection, right? So that is something you want to do, feature selection, that not using all the features. So what kind of techniques we have for feature selection is let's do select feature extraction. Not this, maybe something related to, so so this feature selection thing is there, where you would have gone through this RFE, RFEC. So this is in the lectures explained by Prof, that these all things will be there. So how to recursively remove something, or sequential feature selector, right? So this kind, like, so what happens is uh, let's say RFE if you use, so based on RFE a model will be chosen, right? That use this model. So some model, like let's say linear regression or KNN or decision tree, some kind of model it will use as an estimator uh, to find this coefficient or important feature, right? So this kind of things it will give, and based on that there will be some ranking will happen, and you can choose how many you want, right? 5, 4, 6, something like that. So this importance get answer, something like this is there, and you can then based on the most important value you have to select that feature, right? So you can see n features select 5, so 5 they are selecting out of many, right? So we can also do it. So for what I'll do is I'll just copy this and use it on our data set. So how to do that is I copied all the things, so these things I'm importing. So for now I'll let it be here, but I usually do importing at the first step. So I would have actually copied this, the whole thing, and kept it there, right? So this is something I don't need, which is creating data. So I don't need that. As current feature selection, and X and Y, I already have that. Okay. So estimator is something I'll require. So for now we are using, this is called support vector machine, and SVR is some in that side. We are using linear form of that. Okay, support vector machines. Like here you can see from sklearn dot support vector machine, I'm using this regression kind of thing. That's why SVR. There is another called SVC, which is for classification. So R is for regression. Okay. Now, so this, let's move this to the next cell. But this is the whole code for that. 2 lines, right? That model, you import model, then actually create an object of that model. You can choose anything. As of now, just whatever example is given, I'm using that linear regression, anything. Now RFE is there, estimator n features to select, and steps 1. Okay. So step will what will step do is, so any doubt, right? Why this feature is there? Why should I use it or should I not use it? So you can actually come to this guideline document and read about it. I don't expect you to remember all this thing. So whenever you do this thing and trying it out, you have to come at here, like you have to read the guideline, then think about, okay, if greater than or equal to 1, then step corresponding to the integer number of the feature to remove at each iteration. So some iterations will happen internally, right? That will give this steps, like how many steps you want to take. Like you wanted to remove two columns together in an iteration, or one column, right? So this one, or this number is about that only. Number of features you want to remove at each iteration. Okay. or it can be percentage also if it is float number. So let's do that. Now I will just use our X train and our Y train. So on Y train, I don't need to scale it. Okay, so because I want predictions also in that scale only. Like my Y train, you can see if I show you that it's okay. This is fine. Like it's not that huge. I thought it is going to be as present price. Okay, no issues. So
Excuse me,
something
sir.
on, yes.
Sir, the in the above code you have written import SVR, sir. I joined the session a bit late, sir. Can you tell what this SVR is?
Support vector. So support vector machines as regression variant of that
Okay,
regression
okay,
v.
okay, sir.
Okay. Uh, what did happen? Could not convert strings. Okay, so some strings are there. That is the issue. So what we can do is we actually want this whatever it transformed here inside it, right? I don't want. I'll give numbers only. I will not give this some random strings to this thing. So what I have to do is maybe I can store it to something as of now, like let's say df4 or something, and then give df4 here. So just remember that I am transforming x train only. Like here you can see just x train, and that I'm storing it as a new variable. So I have to give that. I am calling it as d4 now, but y train I'm not doing any transformation as well. So I don't have to actually write it also in different manner, right? Now you can see the ranking is appearing like another thing I should have done this and this. So there's two ways it will show. So since we used 5 as the columns I want, right? That number of columns 5 I want. So you can see 1, 2, 3, 4, and 5, right? So wherever true is there, for which the rank is 1. Okay, 1, 1, 1, 1, 1, and then after that 2, 3, 4, 5, and all will be there. So it's just a way to easily pick up that which columns we are going to choose. Okay, so that's how it is showing you the ranking of one all of them, because we choose to have 5 columns in the final data set, right? Now how does my data set look like is something I have to do is something I have to do is dot fit, but that I did, so maybe I can just transform it. Okay, so this is how it looks like. So this 5 columns got selected. Maybe for this selector, here, right? I can write like set output transform equal to right. So this 5 columns got selected as the top 5 columns. You can get it from here also. It is always going to be in order that which 5 columns are there, right? So let's say x or df4 dot columns, and you can see this is false, so it will not get selected. This is true, so diesel got selected, and it's here also, right? Let's say wherever true is there, 1, 2, 3, 4, 5. So 2, 3, 4, 5 similar individuals, so it's also there, like that it got selected. Okay, so based on this RFE, a model was trained, and based on model you get to know that which features are important for the model. Right, so this every like estimators have something called like estimator dot some coefficient, right? So this if you have done um, linear regression has it, right? Has no, but I'm not saying dual, or maybe feature something wait.
Excuse me, sir.
Yes.
Yes, sir. In today's lesson, are you like describing a particular model like SVM, or are you like
No,
taking a file
we
and
are
using?
not taking any model. I'm just using it so that it's see the code is given to me and I am using it. That's why. So nothing like that. Okay, we are not training any model.
Sir,
Uh,
it,
yes,
it selects top 5 features in this case,
yes.
and those features won't have multicollinearity, is it?
Uh, multicollinearity. In which way? Like
Like these selected features will not have multicollinearity with themselves.
no, no, unique, right?
Okay.
So like you can see, all of them are different only. Uh, so I
Uh, just a doubt, sir. During the one hot encoding, generally we drop one of the column
yes.
just to save us from the same issue, multicollinearity. But here we didn't drop any columns, so there might be this issue of
No, because see, it doesn't affect that way that you have multicollinearity because of that, because um, so let's say now you're saying one more extra column is there, right? It might produce, let's say, fuel type diesel and fuel type petrol, both of them. Um,
which we could learn the category using one column itself, but we are using a two column. That's what my query.
um,
Yeah.
Sir,
could
sir, on
uh,
what basis it selects the 5 columns, 5 features?
so this coefficients you got, right? So you, whenever you train the model, you would get this weights. Weights are coefficients, W, right? Weight and biases. So these coefficients are there. So on base of that, it kind of did it, that whatever, like select this 5 columns, okay, based on this weights given to it. If it was linear regression, weight was there. So in SVR also the weights are there, and this to create the vector and all, right? So so from that it is giving you the most whichever is highest value, right? So something like that will get selected. What we can do is we can maybe do, let's say, estimator uh, estimator dot fit this thing, okay, to get all of the coefficients. Now I will just run, or I'll just try to run this estimator dot coefficients. So it will go give you the all the coefficients, right? So so this coefficients are always in order, right? First column got this coefficient, second column this coefficient, third column this coefficient, something like this. Okay. Now what you want to do is pick up which is highest 5 value, right? So or lowest 5 is also fine, like minus, but too much negative would be important. Like, so absolutely high value is something you wanted to choose. Okay. uh, so uh, then what I'll do is dot absolute to get them as absolute, uh, and then maybe uh, or let's say short. Let's do the shorting as of now. We can do that something later. Not this. Think should do. Okay, so something like this. Now we want highest 5, right? So these are the highest 5. It could be negative also. Earlier I changed them to positive, and that's why this values are there. So I think one of them is this. 6, 7 is here. 0.233. That is, I think, one of this. So both have same value. So I think both of them got selected. Then the final one, right? So this all columns got selected. Now maybe you are thinking which columns are there. df4 dot like columns we can do. So there are several ways to figure out which are there. So like one of these present prices should be there. Is it there? Yes, it's there. Then year should be there, which is also there. So these two are, looks like they are 1, 2, 3, 4, 5, right? So 1, 2, 3, 4, 5. So this two, seller, dealer, and individual. But it took one only. Yeah, fine. So this multi-collinearity or something you are talking about, I think it is already being handled here. I'm not sure does it handle or not, like explicitly, or should we really do focus about it? But I never actually did paid attention to that. That should I explicitly do it? You can maybe do it. If it works, it works, right? Like we discussed that in ML you have to do it. It works, it works. Nothing. There's no guarantee of anything. Now, yeah, another next could be this values, right? 0.15. So which looks like either of them. Which is like 6 or 7. So any one of them could have been there, and one of that is there, and and you can also see like let's say this value 0.25, right? And last is a 0.47 or whatever, something like that should be there, right? So you can figure it out which are there. That is not the like decoding part. I'll leave it up to you, but it's possible. Okay, so everything is happening because the way it is like written in the codes, right? It's already being handled. Like if you are worried about multi-collinearity, maybe you can try on multiple data sets. Is it handling it by themselves or not? Maybe if it's not, then you have to do it. Or if it is doing, then you don't have to worry about it. I think it is doing by itself, because I never had this issue that multiple columns of same features are coming into this. Okay. Maybe for you, if it appears, then you might wanted to remove it. One column, one feature or something.
So one question.
Yes.
Because we are talking about the pipelines, I just wanted to know, sometimes we get the data from multiple Excel sheet. We merge the Excel sheet and perform various activities. So I just wanted to write a code where I can merge the Excels and do some operations in a form of functions. Can I use that function in this pipeline setup so that when I run a code,
Hmm.
uh, that operation would be the part of my pipeline? Is it possible to include my custom function into this pipeline?
Yes, it's possible. You have to write the class of that. So you have to write the class. Right? Some class mention that, then name of that class, right? Then you have to define the methods of that. So you have to give in that way, and it will work.
Okay, thank you, sir. We'll try.
Okay. So Yeah, so now we are here. So now that one step which we just now kind of understood, that how can we add it to the pipeline again. So after this scaling and all, I'll add the one more step, right? So let me just copy this thing and keep it here. Same thing. Okay, so I'm will now create something called like feature selection. Okay, something like fine. Now I will add this thing which requires this two things, right? So first, what is estimator, and then what kind of thing I created. So see, there are several ways to do it, but good idea is that we first create a name of it. So if it's a huge name coming up in the pipeline, then that would be an issue. So what I mean by that is, let's say if I have let's say if I have this, there is one way is I just give this part, okay, inside this. Now estimator, it doesn't know, right? What is it like? Pipeline doesn't know unless you have actually created this earlier and run it. So you have to give that also, that this is my estimator. I stored it in estimator variable, but let's say if I don't, then this is how it will look like. So for now, readability is a little bit compromised. So you have to choose between this. Like, you want readability or you are okay with it. Like, I don't mind. I can understand it. It's my code, something. So as of now, it's okay. You can do it. But I think readability is more important in terms of like whenever you become programmer or something. So it's a good idea that you create this kind of, let's say, variable or something where you store it and just give that. So let's say if I remove the whole thing, like and just give the selector here, that also would work, right? Just this much. And I know selector is this part. Like, I can maybe go up and check it out. What is the selector? How it is coming up? So this is a variable. All of them are variable names except this. This is a class. Okay. Now.
Sir, RFE is used to reduce overfitting.
No, we are doing feature selection using this. So this feature selection is something like how can you select features, right? Which are important features in this. You don't want to use all the features for training. Some features are important than other features. Maybe they can lead to your so the more the features, you know that, right? R2 score, like if you adjusted R2 score, if you are familiar with it, then it will get affected by the number of features, right? And otherwise also, let's say if more features are there, that is not a good part. Like, you have to train more computation wise, it's costly, several things are there. So few columns is better for training a model. So that's what we are doing. We are choosing some columns which are important based on some estimator I used that train it, and whichever features are having higher coefficients in either direction, like negative, positive, are most likely going to be more important features. So I'll use few of them, let's say up to 5, 6. So this number is kind of hyperparameter. You have to figure, like, you have to choose it. Like, it's not that given or anything, right? So this is a hyperparameter. So wherever hyperparameter is, you have to figure it out, any number. So this is the pipeline now. You can see this pipeline is there. Now I just give xtrain here. So see, the idea behind this pipe is that I do fit on xtrain. Okay. And okay, RF estimator require y. Okay, so y is also I have to give. Let's say y train. And it got this. Now what I have to do is I have to pipe dot transform x train. Okay, so let's do first train, and I'll store it as, let's say, x train something as something like this, right? Okay, and So this is what you get after the complete transformation. Now you have to run a model on this, like whatever model you choose. You can choose several regression models are there. Based on that, you can have this. So this is the features you got after it. Okay, just features, not the what you call. There is nothing like now. See, here I don't need to give white trim because I am not actually training anything, right? Fitting is not required here. If even though if I give, it will not throw an error. It will just okay. I think for fit transform it's okay. Set. Yeah, for fit transform is okay, but for transform it's not okay. I didn't know that, but so something like transformation will not require white train. They are useless to them. Now it has learned everything and all. So now we are just converting it, right? So everything is stored there. So what you wanted to convert? X train, I wanted to convert it to this. So I'm doing that. Now let's do for X test. So one thing could be that does it throw an error for the encoding part that I was worried about. So I kind of handled it with some unknown thing, but still, let's see. Pipe dot pipe branch has no attribute trans. Okay. Okay, so there is no error. I think it has handled somehow. So there's no error for that also, right? So it worked. So now you can see I have X test. Now let's say any future data comes up. So let's say how do you say that this is the future data is? Let's say I choose a sample of any random. Right. So this is a sample. It's a three. These are the new samples which appears in front of you. Okay, you never had this. You can think of them as like in future you got this, right? Something like that. Like you never had this. So now how will you you have to clean this also, right? You have to convert them also to a number. So you just have to write like pipe dot let's say transform and then give this X train and like just for sake of I'm using this samples. So sample will help you by doing the sampling, right? So this like the rows change because I didn't use any random seed or anything, but you got the idea that some random another samples got selected and on that the transformation is applied. But this is a new data set, right? So no matter how many time I run this, it will not throw an error, right? So multiple times you might wanted to predict it. So whenever you do any kind of predictions, you have to first convert it to number, right? So now only I can actually train any kind of model. Let's say sklearn linear regression if I wanted to train. So I'll do it for the sake of it. I think in next week it's there how what is there in linear regression. I mean it's just a very simple algorithm, right? So don't worry about it. I think it is in linear model. Yeah, import linear regression. Then model we train is we first create object of this also, something like this, and then just do the fitting on this. So some parameters are there, like let's say fit intercept, you want to fit it or not. In this, there are very few. For linear regression, it's a very easy or basic algorithm, doesn't have much parameters. I think just weights are things that it learn, and then like do you want to fit intercept or not. So this parameter is there, right? So it's simple. Now what I have to do is I have to fit it, but what I will fit? I will fit okay, this thing I wanted to fit. Another thing I can do is I instead of I explicitly do it again and again 2-3 steps. One thing we can do is we can just add one more thing here that this is my model. Okay, we can do that as well. So let's say this is my model in the pipeline, which is going to be linear regression. So it's simple, so I can write it. Otherwise, I would have created a object of this like this and would have done it. Okay. Now this this linear regression is not defined. Okay, to run this. The issue is here. Okay, now you can see this another thing got added, that after feature selection, you'll get this linear regression model. And now what you have to do is pipe dot fit. So now transform will not work because we don't want to transform the data, or we don't want to see the data as transformed, right? We just want the predictions of it, or like kind of train the model at last. So just be careful that whenever you add model to it, then transform function will not work. Okay. So internally it's doing it, but it will not show the output to you that this transformation is happening, right? So I did the fitting part. Now maybe we can learn that pipe. So let's say if I do 0, right? So 0 will give you the first thing. So likewise, you can traverse through it also. So you can see column transformer, then maybe scaling will come up, right? So this is how you can traverse through it. If I write -1, you will get the last one. And then what you want to do is maybe you wanted to look coefficients of this, that what are the coefficients learned by it. So you can see this is there. Then another thing is learn like intercept, right? Intercept in my thing. So this is my intercept, this is my weights of each weights. So this weights and the earlier weights are kind of same thing, but here we train the model, there we use it to extract out the features. Okay. Both are same thing, and but there we use it for some different purpose. Here we are actually training the model. So this is the linear regression is the model which you are going to use for like the rest of the predictions. You will always use this linear regression model, or you can say this is a linear regression model. You will not say this is SVR model. Okay. Because we are going to make predictions on this. Like let's say if I do pipe dot predict something like, let's say x train dot, or let's say x test dot sample, some sample I'm choosing to predict what is the output of that, and you can see these are the output of it. Okay. X test, some samples I chose, and on that the predictions are this 8 and 4. You can have anything, like let's say x test dot sample 2. Does it have random seed? Random state is there. Okay, great. So if I use this, let's say this 2 are coming up right now. This is like 177th and 9th thing. Maybe what I can do is x test dot, let's say ilog. I want rows which are 177 and 9, and I want all the columns. Position indexer are out of bound. I think I think. Okay, what about this? Okay, what about? I think I should use maybe lock. Okay, now it is okay. So lock 9 and another I want is 177. Yeah, so this 2 are there, right? I can see if I write like this. Okay. So why I did this, so that I can I can actually find the labels for this. That's why I did it. So y test dot lock, and then I wanted to use it. Too many indexes. Okay, I think this should not be there, and still too many. 177. Okay. Now before 9 it could be this, right? So for 9 it is this. For like here it's 177, 0.35. Now let's see what are our predictions. So what I have to do is I have to give it here as this, and then make predictions on that. So first one I predicted as 2.75. First is this one only, and like for another I predicted 7.45. So for this it is like very far, but this feature it's low, right? I can use metrics and all, which will come I think tomorrow only. They're not going there. Like you can use R2 score, mean squared error thing that to evaluate the model. So model evaluation on all I'm not doing today there, but this is something you can do later. So as of now, I'm just showing you that you can create this whole pipeline, and then this predictions become very easy. You just have to write this line of code, and that's all. Otherwise, what you are end up doing is you, let's say, first get this data to transform all this thing, right? So whichever we did, you do it in similar way. That first you do this transformation, like imputing you do, then you do encoding, then you scaling, then feature selection of that, then you can train the model. So if you want to do multiple times, reproducibility is very less of that, right? You can't write again and again this whole code. You have to merge it somewhere so that you can do it.
Excuse me, sir.
Yes.
Sir, how you get this image, sir?
How?
Yeah, this image is being shown now on the screen.
How is it showing?
Yes.
So if you create this pipeline and just write the variable name at the bottom, it will show you.
Okay.
So this is the pipeline where I did the storing of this, and then on pipe, I wanted to see the pipe, I did it.
Correct. Let's proceed, sir.
Yes. So this is the complete pipeline to clean a data and then evaluate the model. So at last it has this. Generally, we don't put model into the pipeline. The reason is we might wanted to change models again and again, right? Repeatedly, we might wanted to change it, and so there's no point putting it in pipeline. But it will become difficult to later on, training different models. So let's say if I wanted to train another model, I would have what I would have done is I would have not doing this. I just take out my transform feature and then train it on any kind of model. So you can try it out all the models also, like all the regressor type of models. You can try it out. If you have just this much, right? This much up to this level, if you are there, you don't need this part, and that's fine. That is also okay. So at last, maybe you figured out which one or which final model you are going to use for, let's say, deployment purpose. So after you train this, you deploy it, right? You see some APIs and all. They can you can do deployment of that. For deployment purpose, you can add it again here. That this model I'm going to use for the deployment purpose with some hyperparameters. Everything you have to put it like that. Okay. So training part we will not add it, but yes, after training is over, we create this pipeline again. Just add this part, and then for deployment purpose, we'll use this the whole pipeline. So okay, so it's there now. I think we are kind of set for it. So some feature transformers are there, like RFECV, select. All of them have like similar kind of thing, right? So let's say if I do select K best, what it will do is some kind of statistical thing you can use. One of them is like, so for scoring function, you have to write something like what kind of scoring you are going to give. So generally, it gives the idea that these are the scoring functions it's going to use. That it calls it a scoring function, but it is statistical functions, right? You I think you would have done in statistics too, that how to do chi-square test. So chi-square test will do. So based on that, it will select some columns, and that columns will get you will get back, right? So just simple like use chi-square test here, and so here they are using k equal 20. K is the number that that many columns you require. So this is always going to be hyperparameter, like y20, y not 10, y5 or something that you have to figure it out. There is nothing like um, uh, good value of this. This hyperparameter, you have to choose it. Okay. So chi-square test, they used it. Another thing you can use is regression F score. If you know F score, they use F score for this. So these are all statistical things. You can figure it out. You can search about it. What is F score? So I think if they have given their formula as well, that they will reduce like subtract mean of that, then something like y minus mean, standard deviation of both, and something like this they are doing. Okay, this is not the way I have actually learned F score, but that is okay. They have given it. This is how they wrote the code of it, but you can read about it, right? What is F score? F score. Not F1 score. I want statistics. Okay, so this is something called F score. I think this is not the one I want. F test, right? So sorry, I missed spell, but F test is the one we wanted. Okay, so kind of we are doing is this thing, right? So this is the thing we are doing. For that, the formula was written, some standard deviation and all. They are doing it, but this is something we are doing. If you are familiar with F test, that's what it is. F regression, F classification, both of them are F tests. Okay. One is for classification, like one-way analysis of ANOVA and all things. So this all are statistics. I will not go into it. That is not important for like the working of that is not important to us. What is important to us is you can actually implement this. Okay, so implementation is all important for this course. Like MLT wise also will not go too much into MLT thing. We believe that you have had enough of that, like knowledge about MLT. You had the course, you learned it. Now it's your job to maybe connect it also. And if you are not getting it, you have to read it back, right? There's no shortcut for that also, that why this linear regression or how it works. Then how it works will not explain, but will show how the code runs. Okay. So F statistics like F test. Sorry, I kind of forgot F score with that, but that's okay. Now a few more will be there, like mutual info classification. So this mutual information references, maybe you can read it about that also, that what is mutual information. So this that is Wikipedia, everything is given. It's tough. If you wish to learn, you can do it. Okay. So there's all different kind of scoring functions are used by this select k best so it will use some scoring function. One of this like chi-square F classification mutual information, right? So this kind of thing it will use to select the features, to narrow it down to some value. So k is the number to which you wanted to narrow it down. Then percentile you can choose that I wanted to keep only, let's say 80% of my let's say data, right? Like let's say default is 10, so percentage of features to keep. Always remember that how many you wanted to keep, like 30% you wanted to keep, 40% you want to keep, so rest will be removed. Okay, 1 minus whatever percent is there. Now I'm not sure about that, but variance threshold is there. So if some variable is there, right, which has same value, like nothing is changing in that. I think I'll give an example has like okay, let's see. So sometimes if you don't understand there, you can maybe copy this, come to the collab, like I'm going to do, like this, paste it. Then features currently are not accurately visible, so like exactly like very easily visible. Maybe you can change it this way, and then that okay, first feature is there which has same value, like nothing is changing there. even last value has all the same values. It is not also changing. So I know that variance is not going to be anything, like zero variance. If data is not changing, then there is no variance. So that threshold I have to define. So by default, it's 0, right? So that we can do. And if I do the transformation of this thing, you can see now this, which has 0 features, a 0 variance are removed, but which has non-zero are kept. So something like that also tricks are there to select features. So this all tricks are there how you can select features. Variance or selector, right? So sequential selector will be there. One more thing, this one. So what it does, it also does same way, like estimators will be there. So it will what it will do is, so direction you have to mention like forward or backward, and whether perform forward selection or backward selection. So so what happens is, like forward selection, it will take one feature, train the model, and give the output. Okay, then we will take two features, train the model. If let's say my score reduces, that means that new feature is not that important, right? So the new feature is not that important, might not want to take that. So it will then take the third feature, then do it, right? Or so it will do all the variation of it, like 1, then 2, then all three columns, then 4 columns, then 5 columns, something like that. So it does all the kind of permutation combination, train it, then figure out which columns are going to be important, and it will keep that only. Okay, so this is like something like greedy fashion features to select a subset in greedy fashion. Like at each stage, this estimator chooses the best feature to add or remove based on the cross validation score of an estimator. Right? So this cross validation, have you heard of cross validation? I'm not sure if we ever did it, but so cross validation is what you do is, instead of using one train and test split, you can actually do fold of that, right? So k fold or something is called cross validation. So multiple set you create, and on all of them you let's say 5 set you create, right? So cross validation is something like you create 5 sets, then all you choose 4 to train and 1 to test. Okay, and you do it for all the 5 sets. So first, initially it's the first 4 got selected, then maybe second, third, fourth, fifth got selected, and second will be the test set, and so on. So it will goes like all of them will become test set, and all of them will become train set, in kind of way. Okay, so you can say that, let's say first iteration, my test set was first fold. Okay, first fold is like, you can say 5 divisions are there. I did my data in 5. So index wise, I'm saying that from index or count wise, that 1 is there. So first I'll choose for test set. Then second, whichever is there in the 5, I'll use as test set. Third, I'll use as test set. Third, then fourth, then fifth, right? So this way it will train the model. 5 models it will train. So same model 5 times it will train, and then at last we'll take the average of this, all the values, right? Something like that we do. That's called cross validation technique. So instead of just doing train and test, right? So it's 2 data sets, like train and test, where like I'm using the whole data set of training for the purpose of training. I can, if I divide and do it, then surprising or not, maybe surprising, but the results were found good, right? Because gradient descent or some kind of techniques are used. So which way the gradient goes, that is also important. That which row is coming next is also important for that kind of things, right? So cross validation is a technique which we use it, and yeah, so something like based on that the scores will appear, right? Just and on that it will choose the features, right? So there's several things are there. You have to try it out, that which one to use. Now that is a question maybe you have, that there are several, which one should I use? So there is no actually right answer for that. You have to try it out, some things out of it. So
Excuse me,
maybe,
sir.
you can use RFE. Yes.
Sir, the updated collab, the collab which you have edited, it will be updated, right?
Yes.
Okay, fine,
Yes,
sir,
it
fine.
is.
Because I have to remove it.
Okay. Okay. Uh, where was I? Oh, whatever. Even I forgot. So, is there anything missing now? I think KN and computer is there. I can do that, and that is the last topic of this. If anything else, you can maybe tell me now. Uh, is there anything left apart from KN and computer for week 2, or is there anything you want me to cover? Hmm. So I think I'll take it as no.
No, sir, thank you.
So okay, so I'll cover KNN imputer part, and then um, we can close the session. Right. So what is KNN imputer? Now let's say you have this. This is a row, right? So rows generally you can consider rows as so these are vectors, and you can consider them as a dot. Okay, is it okay? So 3-dimensional thing is there, dot is there, which is at this point. Like if I write, let's say 1 1 1, that means all of them are at 1, right? If I write 0 comma 0 comma 0, that means it's at the origin. The dot is at origin. Okay. And some same way it could be anything like 1 2 3, then along x it's 1, along y 2, and then z 3, and that's how the data is there. Okay, so this thing are there. So the KNN is k nearest neighbor. That is the full form of it. So k is the number of nearest we are going to find. So I think you would have done this KNN classifier. So it's same thing, but here what we are going to do is we will use the distance to impute the thing. Okay, so we'll say that okay, this 5 or 4. You can choose k by yourself, right? That is a hyperparameter. So that k you will choose that this many are my nearest neighbor, and what values do they have for this column. Okay, I will take average of that. So that averaging of that value is KNN imputer. So what happens is now here we have all the values present, right? Nothing is missing. But now let's say something is missing. So this is, let's say, missing, and let's say this value was 4, and let's say this was 0. Okay, now just for the sake of argument that these two are the nearest neighbor. Okay, it could be more rows available to you, but you have to figure it out which are nearest neighbor based on the distance, and that's what KNN will do it. KNN imputer will do it for you. But that is the idea, that nearest neighbor are this. Now instead of npnen, we are going to do imputation. So what we'll do is we will take the average of it. So 4 plus 0 divided by 2 as of now. The n will be, or k is going to be the denominator later on, that just many neighbors you choose and what values do they have. Okay. It's just that way. It's very simple. Now this nearest neighbor finding is little bit different here. So see, normally Euclidean distance would have worked, right? Euclidean distance, you know that we do, let's say, so first and second row, if I do 1 minus 1, square of that, plus 1 minus 2, square of that, plus plus 1 minus 3 and square of that. And then the issue happens is the last, right? What is it? Nothing is there. Like, then should I consider 0? Maybe 0 is not a good idea, because somewhere 0 is important, right? Here maybe not, but somewhere 0 is important thing. So that's not a good idea to say that np.n I take it 0 and then compute the distance. So what they do is, instead of I have to take under root also, right? So that I'm not doing, but you have to take under root also. So what they do is, instead of using all 4 points, they use 3 points. That's all. That's a simple trick they use. That let's find whatever dimensions I have, along the dimensions only I will find the nearest neighbor. Okay, is that fine? So this using this, they will be able to figure out which rows are nearest to each other, and then they can do this values which they wanted to impute. So imputation will happen like this only, averaging of whatever values present to them in that column. And but the finding the nearest neighbor will be done using the Euclidean distance. Okay, so Euclidean distance will help you, or they call it as non-Euclidean, just a name of this, non-Euclidean distance, to find the nearest neighbors. Okay, or as many you want, k you wanted always, so k nearest neighbors. Okay, now imputation is of course this, right? So take the mean of that column. So that column you will use. So column wise you will do the imputation. Okay, that first, second, third, fourth column is there. So take the mean of fourth column for the nearest neighbors. Okay, so just simple that you first find the rows which should be there and then take the mean. That's all is there. Now let's say if I go to KNN, there's one issue which might always occur to you is simple imputer doesn't have any issue with having strings in it, right? Some kind of object or non-number values are there. That is no issue for simple imputer. It can find mod of that at least, right? So most frequent value it can do it without even you giving it the strings. Okay, but this thing is k nearest neighbor. It requires all of them to be number to find the distances. So it's a little tricky to use it. That you first have to convert them, all of them, to numbers first, then you can do it. So after that you can maybe do the transformation. Okay, so basically what happens in this is, first you somehow handle all the, if you wanted to k in an imputer, the issue is it takes some few more steps, but you can do it. First you have to do encoding of categorical data, right? That you do first. Now let's say something are missing in this categorical data. What you will do? You will first impute that using simple imputer, because there is one thing you can do is finding mod of that. Like there is nothing statistical about categorical data, maybe median for ordinal data, but that also you have to do using like something you have to do to do that. Some other techniques are there to imputation. You can research about it. So maybe somebody would have researched about it, that how to do imputation, very like some high level functions, how to make that. They would have done it. If you do that, but still you have to do this encoding for categorical part. Then for the numerical data, which are numerical columns, like year, present, price,
Sir,
something, all that you can do this KNN imputer. Yes.
so like, do we do encoding and then do the imputation, or is it okay if we impute before? And
That is okay. Both ways are okay.
okay.
Okay. So, but what I generally do, so something you have to always follow. Okay, like whichever way you go, first you do this and that or something, you always follow that way. Okay, don't change in between that. Okay, after some time this thing happened. But why I use encoding first or imputation first, then I do the encoding. Okay, because if I do imputation first, then I don't have to worry about null values, right? So null values are handled. Now I can actually easily do the encoding. So that's why I use this way. But if you do other way around, then you have to first be careful about null values. So once or twice you will do it, then you will realize how to actually handle this. Okay, not an issue. But you can do other way also.
Yeah.
Most likely it will not change. In like much change it won't be there. Okay. But for numbers like numerical kind of data, I think this is the order. First you do imputation, then do, I mean, okay. So for that encoding is not this. Sorry, it's not there. But
Also
some
for ordinally encoded, like do we standard scale them later or
yeah, we can do the standard scaling.
on
That's on.
ordinal also?
Yes, on ordinal also. So what happens is, let's say you have these values between like, let's say 0, 1, 2, 3, 4, 5, something like this, right? If you do the scaling, it will be in like, so now you will know that, let's say you use standard scaler, okay? So it will find the mean of it and subtract from it or something, right? So just for the sake of it, let's say it took like maybe, minus 2, then maybe minus 1, then something like, right? Or it not be necessary that it's like this. Maybe it could be like this also, 1.78 or so, but you will know that 1.78 minus 1.78 is 1, like category 1. That's what it is indicating. You'll be able to figure out. You can do the encoding, check what values are there. They are also going to be in like 4 to 5 categories. That kind of values you will get in that. But
So
now we are reducing this different numbers.
so if I have a pipeline for like my ordinal columns, so I can first pass simple imputer and encode, sorry, like impute with the most frequent or
Yes.
something, and then encode it, and then again in the pipeline pass the imputer for standard scaler.
Yes, you can do that. So that's why this pipeline is very handy, right? You can write this pipeline in several different ways. So whichever way you want to do, you can do that. First imputing, then some scaling, then again you wanted to go and do imputing of different kind. Let's say this sklearn, this KNN imputer thing. Then that is also all possible. Like I would have, let's say, imputed all the maybe categorical data. Then I would have encoded them. Then I would have used, let's say, KNN imputer here before scaling it. Then I would have scaled it. So it won't be much difficult using this. So some kind of things you have to keep in mind, that you might get these errors of columns. So as of now, what I am doing is I am careful about it because I know it. You might not know it, so you'll make this mistakes. Mistakes are that when I write the column transformer, I mentioned the column names, right? So this thing will give you error that this column doesn't exist. That error you will most frequently see it. So you have to be careful that column names you have to maybe check that what are the column name I'm getting out of this after transforming this. Or there is another way is use indexes. Like you can use actually not using names, but like 0, say 1, 2, like this thing you can do. So this is index of columns, right? So let's say xtrain dot columns. So this will show me the columns. Now these are indexed twice, right? So if I wanted to get, let's say, 0, 2, 6, so this columns I want, I can get this. I think what I am missing is okay, it should not be okay, 0, 2, 6. This way. Okay, so these are the, so this is basically indexing of the array, but you just have to mention this only, like just this part, like okay, this, like, just that, and it will work. So fuel type, you can figure it out that the column is going to be the 0, 1, 2, 3, 4. Right? So 4 I would have written here in integer. So be careful that I'm giving strings here because it's a name. Otherwise, integer is required. If you use indexes, then indexes are always in integer. So not putting this quotes around as don't miss that. Transmission, so something like second last, whatever it is. So you can choose that, and like I think 6. Okay, so that you can do. So if I write it say 3, 4, 5. Then I use select type. Okay, so I think 4, 5, and 6 would be the. So this things I used, and that thing like will work here. I can maybe show you as well. So this is another way to write is I have to use not just names but the index like 4, 5, 5, and 6. Same thing, you will get the same thing, right? So you can see, but now of course this naming and all something like this. I use name here, so it's there. For car name, I can do 0. So 0 is something I have to do here. Okay, like this. So in this pipeline now, maybe you might not get it which columns you are doing, but that's okay. You can since you wrote the code, you know which is that, right? Um, so this is another way. If you are getting lots of error of like not found columns, then maybe go with the numbers. You can maybe before writing this numbers, you can say that okay, this columns are going to get this numbers, and just for the reference purpose. As of now, like when you are learning it, then later on you won't need such things. Okay. So yeah, it's there. Now Kane and impeller all sided. So I think if okay, any other doubts? Otherwise we
Sir, have we covered fine tuning?
fine tuning. Okay, it's there in this week. I am okay. It's there. I haven't covered it. No, I haven't covered it. But fine tuning. Okay. Now this is a tricky thing without a model or something. But okay, this is no. It was in week. Wait, it was in last week, right? The fine tuning. Or no, it was in this week. A demonstration of data imputing scaling method, transformation, composite transformation. So that is column transformer. So okay, pipelines entering imbalance class. Okay, so PCA and something we didn't do, but I think this part was there in last week. It would have been covered, but none. That's okay. It's very simple. What you have to do is you have to write either grid search CV. So CV is cross validation, right? So folds, how many folds you want. So based on that, they given this name as grid search CV, right? So first you have to create a grid. So for that grid, you might wanted to import the grid search CV. So what I can do is I can come here, say import that. So from sklearn dot what is it, model selection. So grid search CV. Okay. So this is there. Now I think so this thing I have to give. A few parameters are there. So this grid search CV, what it will do is whatever parameters you give, right? So it will actually create a grid. Like how should I say this? Like let's say you give first parameter is there some let's say I'll call it as 1. It has like you given that choose this value 0, 3, 6. For some reason you give this. These are hyper parameters, right? So you have to change, you have to look for this. Like there is no such way that why these parameters are only chosen. These are hyper parameters. You have to give a range of this and let the grid search CV believe on grid search CV that this hyperparameter tuning will actually choose the best one. Okay. So param 2 will have, let's say, values like I don't know, some it can be string also, right? So now let's say which one should I use? You want to use L1 regulation or L2 regulation, right? So regulation, I think you would have learned it. So I'm using that L1 or L2 or something like this, right? So this kind of thing you can choose. So now what is grid is, it will take model. So let's say model 1, or something you can call like param 1 and param 2, right? So this two parameters will be there. Now it will take all the combinations. So what it will do is, it will take 0 and then let's say L1, right? Another combination could be the another combination would be this with L2, right? 0 with L2. Now it will do with same thing. It will do with like this, right? So it will do again with same thing with when value was 1, 1, and then value was, okay, not 1 but 3, 3, and then value was 6, 6. Okay, so this is how the grid is happening, like 3 cross 2. Okay, so actually it's forming a grid. Like if you plot this in a like grid kind of thing, then you will realize that it's actually a grid kind of structure, right? All of them are being connected to all of them, like that. It's there. So this grid like structure will appear if you draw it across. So if at the edges or at cross section you write these values and try it out, it will form the grid. Okay, all the parameters it will take. So out of this grid we are picking one at a time. So this thing, and then train the model, this thing, and train the model. So all of this thing will get trained, and then we'll get the sum output. Okay, so we'll get the best model with the, you can choose which what do you call which hyperparameters you wanted to keep it. Best hyperparameters you'll get it. So that kind of thing you'll get it. Now for this I'll just use whatever grid search CV has as the example. But you get it, like you can use any model, right? So just now we trained linear regression, but if it would have been like little difficult model, then maybe you can get multiple things for that. So okay, what I would do is I have to just copy this. Okay, that's not a great idea, but let me write it. Okay, so what I'm going to do is, first I'll create what are the parameters I'm going to use. Okay, you have to give the dictionary in this, like let's say for kernel I'll use, so something kernel will come up in linear in support vector machines, that you want linear RBF is Gaussian kernel. Okay, you might be familiar with Gaussian kernel, but that is same thing as RBF. Then another kernel could be I think some higher dimensional kernel or the polynomial kernel, right? So this thing you might want to do. So you have to give this dictionary and give the feature parameter name here, which is in sklearn SVC. So you might wanted to check out what is SVC of that. Currently we use SVR for our model, for our data. So I think that let's use SVR only. That would be actually better. Okay, so what I have to check is SVR. I have to go there and I have to see what parameters it has, right? So let's say kernel it has. So kernel which has this all values. Okay, so maybe you wanted to say copy, or you have to choose here that which one you wanted to keep, right? You don't want to do with all of them. Some might not work. There could be several reasons, but yeah. So this all are supported by this SVR. So I'm keeping them all, but you don't have to do that. Now what I'll give. Okay, so this is what a dictionary I wrote, and maybe the dictionary will require key and the value. Value will be what are the parameters you are going to use. Okay. Think, here also I made a mistake. And now fine, right? So this dictionary I have to write. Now what else is that degree. Now maybe let's say degree will be only useful when you are using polynomial kernel. So if polynomial kernel is there, then degree will be useful. Otherwise, it won't be there. Maybe C value is also a good parameter. So that's okay if you don't understand now why I'm using this, but something when we cover the models, this parameters will come there. Then I can so dictionary will require comma here, right? Let's say 0.251 something. So this kind of thing you can test it out. So this is my parameters. So based on this, I can actually figure out what is going to be my grid size, or what is going to be the dimension. Like let's say how much is 1, 2, 3, 4, 5 cross 3, right? So 15 models will get trained. So 15 models will get trained using this parameter grid. You can call this maybe grid. Okay, so this is there. Now what I would do is I have to write the grid search CV, which I already I think imported at top, right? So I have to give first thing you can see what is asking. It's asking for estimator, which estimator we are going to use. So maybe we can give this thing, right? So from SVM I'm importing this SVR. You can write directly like this. There are several ways to create this thing, right? Like let's say from sklearn dot svm importing svr, right? So this thing I can give here directly like this. So this is my model which I'm going to use. So I'm giving class directly. No need to create object of this and do it. You can do that if you have like written inside something, you can do that also. Not an issue. Okay, so class object both will work. Same thing. Then I have to give my some more thing, right? So what more thing are there? It's created that if you read this, a param grid is required. So param grid is what we created here. So these parameters are going to be my param grid. Now what else I need? So you can give scoring. So what kind of scoring you want? R to score, mean absolute, error. I think mean absolute is not a scoring function, but negative of error, that is there. Some negative mean absolute error is a scoring function. That thing we can use. So something like that you can give. N jobs is something how many parallelly you wanted to work with. So if you give -1, that means all the parallel computing, whatever you have available, use that. Okay. So you want to do this. So CV is something which is actually the cross validation which will do. So how many folds you want to do, right? So if I write 5, that means for 15 models, each model it will train on 5 folds, right? So 5. So total models actually will get trained is like 15 into 5. Okay. If I use CV equal to 5, if I use CV equal to 3, then 15 into 3, 45 models will get trained, or a little 75. So depend on the CV, that many models will get trained, like total models. Okay. Not different combination. So same combination models. So this other. Right. Now I wanted to store this thing in something, like some variable you can choose. Let's say classifier, anything you can use, CA, grid, or anything. That's not an issue. So yeah, so this is how it looks like. Now I want to do is fit. If I give x train, that is going to be issue because that is not being what do you call? So what I have to do is I have to maybe do some kind of first I have to do this cleaning here, right? So this will help me convert numbers, text to numbers that I have to do, and then I can do it. So text to numbers I can convert, and then I'll do fit whatever x train, right? So as of now, I will just for the sake of it, I'll just take some thing I can do is will I run that? Or should I just do it? Yeah, let's do this. I think that's not an issue. So before I do that, I need to do this, but I don't need model now because model is going to be my grid search CV. That's why I said that don't do it when you are in training phase. Just do this. So this is my pipe. Now I want to do pipe dot fit x train comma y train, and then I'll store it as, I think I already did this, right? So x t r r something like this. Random name I use, and these are features only, right? So I'll use this, but I would have done this thing only, right? So same thing. So yeah, that's great. Now I have something. Just something, yeah. Y train to fitting, and x should be square kernel matrix. Square kernel matrix. X should be squared. I think it is for pre-computed or something that sigmoid is okay. Not this. Okay, classifier. Now I want to fit that. I use classifier. Why did I use classifier? It is not. Maybe regressor is a much better choice. Okay, so regressor. Let's say regressor dot fit x or comma y some. Okay. So you'll get this errors. 12 fits failed out of 36. So 36 means, like, why is that? Because I removed things. So you can see, let's say 1 2 3 4 4 into 3 12 and 12 into 3 for cross validation. So that's why you got 36 total fitting will happen. And out of that, 12 failed, and there could be some reasons like will be set to nan raise. This errors actually happens because some parameters are not compatible with others, or this kind of data also. It could be possible, right? So that whatever data you're giving, it's not working well. So this kind of errors you might see. Maybe you can ignore it also. So this training didn't happen correctly. Okay, so that is like normal. It happens. Some are not, some parameters are not adjustable with others. So now a few things you might wanted to look into is what is so this regressor. It's so .cv results. So this will give you this thing. I always don't like this way, so I convert it to data frame. And I get this. So this is much better actually. So mean fit time, it took this much for fast model. I think it is okay. So so why there are 11 only, or why? Okay, so why there are 12 only? Because this 12 are different configuration, unique, right? So those only it will show. And not all of them. So in that, this 5 4 I think failed. So that's why nothing is there. But whichever worked has it, like 5 5 cross validation of each different kind of combinations got trained out, and then averaging of that, it will take, right? So that's why this mean score and all, you can see mean test score, right? So mean this is standard deviation of test score, and then ranking is there. So which one is best? So this is best, and the parameters are if you use linear kernel and c equal to 1, that would be the best choice of thing. So that you can do is you can, so params or not params, I use regressor, sorry, regressor dot best params. If you write this, you'll get the best params. So these are the best params that you use. See, now regressor is trained, so you want, you know, best model like out of this. So you don't have to retrain this, or you have to explicitly again do any kind of training. It's already there. Now you just have to get this thing right. So how will you do a regressor? Okay, dot best model or something like that. Estimator, best estimator, that is the C. You can see C equal to linear kernel, right? So this is the best estimator. Now you can do predictions on this. Not an issue. Like let's say dot score, if I wanted to comma y, okay, it's something you can do like this. So this much score you are getting. So this is R2 score as of now. You can do it with other scoring as well. And here the scoring, you can see mean test score is for first is 0.85. So this is using cross validation. This is just the score, like computation is different. It's mean taken out of 5 model. It's just taking out one thing and doing this, giving you the score. Okay, not the averaging or something. Okay, so yeah, so it's there. So this is how you can do the what you call hyperparameter tuning. You have to mention this as a dictionary, what you wanted to train for. So which parameters and what are the values you are going to choose, and on that way, like using that, it will create a grid structure, and then on grid it will train. So you have to use this maybe parameter names and all, CV, how many cross validation you want to do, and then just training. So it's simple. Another version of that is random search CV. So that thing also you can explore. Same program like coding wise, just parameters will be there. You can change it, but in random search, it will not do the whole grid search, right? So in grid search, we had all the models got trained. There you have to choose the number, that how many random models you want to choose, 10, 15, 20, that number you will give, and that many models get trained. Okay. If you give number larger than the total like possible numbers, then it will train all of them. It will, I think, not throw an error, but it will train all of them. So you might want to choose a subset of this models. Okay. Yeah, so I think that is also covered. So hyperparameter tuning. Okay, fine. So is there any doubt? Okay, then maybe we can close this. Yeah, good night.
Thank you, sir.
Yeah.
Thank you, sir. Good night.
Yeah, good night. Bye.